I'd like to invite to the Halil Cem GÜRSOY to the stage.
So thank you very much for attending my session about Kubernetes, Docker, Swarm, and other orchestrators. And I will talk to you about which container orchestrator should I take, or should you take. So first of all, I will introduce myself a little bit. I'm a senior solution architect at OPITZ Consulting. This is a mid-size consulting company in Germany or mid-Europe. And I'm building software, especially Java software, the economy, since 20 years. But before that, I have implemented stuff in Pascal or C or Lisp and other languages in the scientific part. But last 20 years, I have done, I am in the Java world and built very large enterprise systems, banking systems, insurance systems, and especially regarding the build, deployment, and persistence in these systems. And last but not least, I do DevOps, infrastructure as code, automation, and I have said, okay, I come from the Java world, but the last 3-4 years, I have not written any productive Java code anymore, mostly in Go or in Python or something else, doing infrastructure as code and DevOps. And this especially with Docker or in general with container technologies. I have a long journey with Docker behind me. I started with Docker 0.8 and Go productive with a customer. And this was a really early version of Docker to Go productive. And it was sometimes a little bit of pain to use it. Not sometimes, very often. But it got better. And we have built large environments, test environments, build environments for large-scaled agile projects. And when we talk about large agile projects, I don't speak of 5 or 10 developers. I speak about 5 or 10 or 20 Scrum teams with 10 or more developers and engineers. So these were very large teams and projects, and we have used very early Docker and container technologies to support environments for these teams so that we are able to start up, to deploy very fast their own test environments, to go and deploy different versions of the applications and not to wait for example, the provision of any servers by their operations teams. So this was a subtle introducing of DevOps. Not telling it DevOps because it was a bad word for management and projects, especially in large companies, enterprise companies. 5 years or 4 years ago, when you go to a large enterprise company, for example, to a banking company, to a bank, and you say, hey, let's do us Agile and DevOps. They say, oh God, go away. We don't do DevOps and new things like this. This is bad things. This is evil. So I don't tell it DevOps. I told them this is an easy way to support you, and the developers can click one button in their Jenkins and develop in a new environment, and you can go look into it, and it's fine. So I built on base of containers and Docker's continuous delivery environments, and using Jenkins or Bamboo, especially with Docker Swarm. The last time I see more often Kubernetes or customers demanding Kubernetes. But I told it I have some Kubernetes phobia, but I'm using or experiencing this exposure therapy. I'm working daily with Kubernetes, but I have my pain with it. So what will we look today? I will take a look at Docker Swarm, at Kubernetes, and OpenShift, or Origin, and to Nomad. I have a logo of Rancher here too, but I will not go into the deep with Rancher. So, okay, let's start and let's go into the details. It's all about containers, how we ship containers and how we can get these containers working together, how they can talk together, how they can communicate with each other, how I can ensure that my application which I have deployed on an orchestration or container system, how can I ensure that it is reliable, working, for example, 24/7 days. And my motivation to make this talk especially was, I saw this slide at a conference, and there's one guy from Zalando. Zalando is a large, I don't know if they are in Turkey too, it is a large company in Germany. They sell shoes and socks, for example, and we have a large built up in few years, a very large business, and they sell socks, for example, and they say, hey, when we sell socks, then we can, or we need our own Kubernetes cluster. And I thought, why they need their own Kubernetes cluster? What was their decision? To run their own Kubernetes on their own servers in their own data centers, for example. And I remembered things from the past. For example, when you have worked in large enterprises and you have worked with databases, for example, we were confronted with things like, hey, we have this large enterprise database license from this company from the US with a large O inside it. And we have this one, so you have to use it in your project, regardless if you can use it, if it fits into your requirements and demands or not. For example, you need to build a large graph, a network graph. You can do it with a relational database, but it is a pain. Why not taking a graph database? They say, no, we have a license for this large enterprise database. Use it. So this was some kind of one size fits all. Take it and it will fit to every project. Really? I don't think so. And what can happen to you when you go and make the same decisions for, I call it, license-driven architecture? The license politics of your management implies which architecture you choose for your environment. What can happen? Something like this can happen. You can wreck your ship while your containers are running and shipping. So this is a bad idea, and we want to prevent this. And my motivation to talk about it is, hey, tell the people which opinions are available, what they can choose. So a little bit about platform classifications. So we have, when we go in and say we have some platforms, different platform levels. So we have infrastructure platforms, container platforms, and application platforms, IaaS or CaaS or PaaS. So when we map some different applications to these platforms, we can say, okay, something like Docker Swarm or Docker DC and Kubernetes are something like container platforms. But OpenShift or Nomad maybe are much more application platform, as a platform as a service. And this we have to keep in our mind when we talk and go further, when we discuss several points of these products. So let's look at installation and post-installation on these tools. So when I look at the ease, how easy it is to deploy, for example, Docker Swarm or Kubernetes or OpenShift or Nomad, I would say the easiest to install by myself. When I talk about these things, I talk about installing or using these things on-prem, not a managed one. So my opinion, and it's always my opinion which I talk about here, is to use or to install Docker Swarm is the easiest. On the other side, when I go in and try to install an enterprise-level Kubernetes cluster, it is very, very hard. It is very much effort. Same with OpenShift. Nomad on the other side is very easy. And to come back, let's say enterprise-level Kubernetes. Enterprise-level Kubernetes is not Minikube. This is very, very important. So support by provisioning tools, where it is some difference. Where are some tools, minor tools on the Docker Swarm side? Where are some tools already upcoming for Kubernetes? Without these tools, it's a pain. But already you told us in the last talk about KubeSpray to use it. This is one example of these tools which are supporting a deployment of a Kubernetes cluster, but out of the box support by, for example, Ansible or Puppet. You have to implement it yourself maybe, or take something from the community, but the quality is very different. On the other side, the learning curve, how fast I can adapt these things and learn this platform. On this side, at this point, Docker Swarm is again, in my opinion, the best one. You have a very steep learning curve where you need a long time to learn the details of Kubernetes. It's like Git, for example, and Mercurial. Mercurial has had a handful of commands. On the other side, Git has a very, very large, thousands of commands, and you need a very long time to learn all commands. It's like VI. It's thousands of combinations of keyboard, and I learned 10, and it's enough for me. Internal structure. What I do mean with this, I can say one point is how many binaries or how the binary is set up or the internal architecture of this thing. So at Docker Swarm, we have only one single binary. Regardless of it is a manager node or a worker node, I have only one binary, and I tell this binary, hey, you are a manager or you're a worker. On the other hand, Kubernetes has many components, different components, which I have to handle. 6 at the moment, I believe. And OpenShift has much more components we have to manage too. On the other side, Nomad has, again, one single binary, but with an asterisk there, because when you run a Nomad cluster or high availability, you need some components in addition. Do I need plugins? Yes, I need plugins. some at Docker Swarm, but when I come back to Kubernetes, I need, during the installation time, I have to think about, okay, which networking plugin I have, or can I use? Which are my recommendations, or which are my requirements? Which network plugin I need? Which storage plugin I need, and so on. So, whereas especially regarding network, there are not so many inbuilt plugins already on the other side. At Kubernetes, there are many built-in storage plugins coming out of the box, but for example, in Docker Swarm, where you need to install all these storage plugins when you want to use storage cluster-wide. High availability setup and usage is the same here. Docker Swarm, it is easy to set up, only one plus because of the stability of this. But in Kubernetes, it is very complex to set up, and OpenShift much more. And Nomad is the same. So you see, all products have some issues, in my opinion, with high availability. So when we go in more details, for example, when I take Docker Swarm, I can take 3 or 5 managers to set up a high availability cluster with few command line commands, and the communication is internally by the WAF protocol, but it is very unstable when you have an unreliable network. I have observed it at many customers' networks that they have to fight with, for example, UDP package loss. In this case, you lose very fast your WAF consensus, and you can come into problems. And same applies to Kubernetes in some kinds, because when you want to run Kubernetes in high availability, do you have to set up etcd, a high available cluster, and you have to fight again with network issues maybe. You have to ensure that your network is stable and that your etcd cluster is stable, because it uses Raft too. And same too at Nomad, and here you need a console cluster at least, an HA console cluster to set up Nomad in high availability. So, summing up, all of them have to fight with split brain situations and unreliable networks. Coming to operations, administration, they are all the same. Most of them use CLI or REST interfaces. Some support web UI. But when you have to manage large clusters of Kubernetes or Docker Swarm or something else, you don't want to do it with a web UI. You can look on it to get some information, but the real management you will do at the command line or the REST interface because of automation. You want to automate the management of these clusters, and you can't automate it when you are using always a web UI. At the monitoring side, Docker Swarm is a poor boy. It doesn't support very much to monitor it itself. You have to build everything by your own. At Kubernetes, with some additional work, you can get some good working monitoring. On OpenShift or Origin, it is very good. At Nomad, the same as Docker Swarm. And log aggregation, again, when you deploy something and you want to aggregate your logs, this is inbuilt already in Docker Swarm, but when you can gather these logs from different hosts and from the containers which you have deployed, the same applies for Kubernetes, but you need to do some additional work. When you deploy Origin or OpenShift, there's already prepared stuff to use the Elk stack. coming to things like deployment. And think you are talking about things to deploy microservice applications like this, for example. Here we see the so-called wheel of doom, where are hundreds of or dozens of microservices talking with each other. And you have a very complex interaction between these applications. And you have to ensure when you deploy a microservice application or application built on a microservice architecture like this in your orchestration platform, you have to ensure that these containers, these services can talk to each other. And this is not so trivial because there are many points which can influence this. So the complexity of deployment itself, when we look at it, it is not so complex at Docker Swarm. But when I look at Kubernetes, I have to fight with YAML. My feeling is that I write 10 times of that which I write in Docker Swarm in YAML. Endless YAML files. And in OpenShift, it is not so bad, and in Nomad too, but in Kubernetes, for example, when you not use any helper tool like Helm, you are lost in the YAML hell. So rolling updates are supported by all products, canary deployments, whereas Kubernetes very good and OpenShift, but Docker Swarm is in this point very poor, in my opinion. And blue-green deployments, the same for Docker Swarm again, but it is easy to implement at Kubernetes and OpenShift. Rolling back, you need it. And if we would have more time, I can tell you the story about missing rollbacks at the Knight Capital. When you have time, you can read it. Knight Capital, the New York Stock Exchange were lost in one day. We are a wool company because we are not able to roll back. It was a very bad thing. Application support, auto-scaling, it doesn't work in Docker Swarm. You have no auto-scaling. You can use some tools which are not maintained anymore. In Kubernetes, you can use the horizontal pod autoscaler. In OpenShift, it is already built in everything that you need. Service load balancing, it is, in my opinion, built in. You don't need to do anything in Docker Swarm. You have automatically load balancing. In Kubernetes, you have to configure, you have to expose, you have to define your load balancer service and so on. And support by service meshes got more important in the last time. We have to say that most of the service mesh frameworks doesn't support Swarm, like Istio or Linkerd. But on the other side, they support always Kubernetes, for example, or OpenShift. And last but not least, community activity, market share. Kubernetes is the market leader. They have the most stars at GitHub, for example, and the most questions at Stack Overflow, followed by OpenShift. Nomad doesn't play where they have a very small community. Docker Swarm, okay, because Swarm or Swarm Kit is not very differentiated from the rest of the Moby project. You have to take care of it. So, looking at or summing this up, which are the main points which have to look at it when you do decisions? One point is, again, complexity. So when I look at Kubernetes, for example, I see architecture diagrams like this, or like this. So, which implies automatically, okay, it is very complex architecture, but what you have to keep in mind is that you have to manage this infrastructure and you have to run your stuff in it, and it is not comparable with Minikube, for example. And deploying into Kubernetes is, for example, a complex thing. So let's look if it does work. Yes. For example, this is a deployment of OpenFast. This is a serverless framework. On the left side, this is deploying into a Docker Swarm cluster. On the right side, this one, it is the description, documentation of a deployment into Kubernetes. And you see it is very large. It is much more documentation needed. It reflects how complex it is to deploy something into Kubernetes and how many ways exist. And once again, you are confronted, when you are deploying applications into Kubernetes, you are confronted with YAML hell. And the complexity is some kind of thing which is, in my opinion, worshipped by engineers. When I have to choose between a simple structure and a complex structure, most of the engineers which I know tend to use a complex one. Because why do it easy when can I do it complex? Because it is a challenge for me. I can, when I do a complex one, when I manage a complex one, I have managed it, so it works. But on the other hand, we had the DevOpsDays. How about DevOps and orchestration platforms? You have to, on one side, you have these very large YAML files for deployments, for example. You have a very complex infrastructure. Does it fit with DevOps? You wanted to take a picture? Manage? I will provide my slides too. So final thoughts about it. You have to keep in mind that Minikube is not Kubernetes, enterprise level Kubernetes. I see so in the last years, I see so many blogs, how to deploy in 10 minutes your microservice application into Kubernetes. And you read it in 10 minutes, and they describe how you can deploy it on Minikube. But Minikube is not Kubernetes. It is a large difference to manage and run Kubernetes clusters instead of this one simple VM on your laptop. The same applies for Minishift. It's not OpenShift. It is much more complexity involved when you use OpenShift. Kubernetes setup and operations is very complex. And deployment into Kubernetes without helper tools, additional tools, is a real pain, where US guys say it's a pain in the ass, and this is true. And in my opinion, especially infrastructure or orchestration tools or platforms like Kubernetes make the wall higher between operations and ops and development and thicker. So we come back again to the level where we see, hey, it works on my infrastructure, on my laptop. It doesn't, it's not my problem when it doesn't run on your Kubernetes cluster at operations. Because of this, hosted Kubernetes should be preferred. Some guy told at a conference, good friends, don't let run you your own Kubernetes cluster. Take your, or use and manage Kubernetes if it is possible. And OpenShift or Origin the open source base of OpenShift or Rancher are good alternatives for Kubernetes. But running Origin or OpenShift is much more complicated. On the other hand, Rancher is much more lightweight because it abstracts much of Kubernetes infrastructure hell. It helps you in this case. And they have managed in the old version, there was a possibility to overcome the YAML hell, but they have dropped the support for Kettle. It was very good. And coming back to Docker Swarm, Docker Swarm is very fast configured. It is stable most of the time when you have a reliable network and infrastructure. It is easy to use and stable. And deployments are with small YAML files. They can get large depending on the application. But unfortunately, it is not honored by the community anymore and by Docker itself, in my opinion. And since Docker Incorporated has announced their integration of Kubernetes into Docker, the work on SwarmKit and the related libraries has been decreased. So, unfortunately, there are no silver bullet to say, hey, you have to always take Kubernetes or always take OpenShift or always take Docker Swarm. You have to choose, you have to look which kind of orchestration platform do I need? Do I need really a Kubernetes cluster, for example? Did I have or did I need to provide a container as a service platform? Or did I have a small project with, for example, 10 containers for my whole company? In this case, I would say something like Nomad or something like Docker Swarm would be enough. So at the end, you have to read and you have to look what are my real needs, and regardless of what the management says, it's your architecture, you build it, you run it, and it's your decision. Thank you very much. Any questions? Okay, thank you very much.
Thank you.
Teşekkür ederiz.